let's talk about angles of triangles. First of all, let's classify some triangles by their angles, and if we remember the words to it, we can also classify them by their sides. So we have a triangle MDE that has a right angle, so it's called a right triangle. And when the three sides are not congruent to each other, we call that scalene. The second triangle below it, EMN, has three unequal sides once again, so it's also scalene. And because all three angles are less than 90 degrees, we call that acute. In the lower left, triangle MLN has a right angle once again, so it is a right triangle. But because two of the sides have the same measures, we call this an isosceles right triangle. Moving on to triangle ENK, we also see two congruent sides, and this would be an isosceles triangle once again. And because it has three angles that are smaller than 90 degrees, we call this an acute isosceles triangle. The triangle below it, triangle FNG, has an obtuse angle. 120 degrees is more than 90 degrees. And because it has two equal sides, we will call this an isosceles triangle again. Up above, triangle EKH has an obtuse angle at 104 degrees and three unequal sides, scalene. And finally, our giant triangle FHG, has three equal sides. We call this equilateral. And because all three angles are 60 degrees, we also call it equiangular. And it's also acute. All right, so we're going to talk about some interior angles and some exterior angles as well. So your interior angles of a triangle are the triangles that are on the inside of the triangle. So we can shade those. 1, 2, 3 interior angles. And our exterior angles are found when we extend the sides of the triangle. And so our exterior angles are going to be outside the triangle. Now, if you have a Post-it, there's a neat way to help see how these angles relate to one another. You can take the sticky part of your Post-it and draw a segment along that sticky part. That'll be one side of our triangle. And then from there, draw any old triangle that you'd like. Straight edges are welcome because they do a nice job of making sure that you get triangles that have nice sides. And we want to extend one side of that triangle. So we have a triangle with three angles, interior angles, and let's shade those angles. Let's shade one of the angles with a highlighter. Shade the second one with another highlighter. Two that have the sticky part behind them. And let's label those two angles angle 1 and angle 2. Then if you take a scissors and snip just a portion of your triangle, so if you snip just along this edge, for example, a little bit beyond the one, and snip along the edge of the other, just beyond the number 2, but so that you still have color left in, then you can tear a piece out of that angle. I'll do my very best here. Try to gather some of that angle, little edge that would normally be torn off. Lasso it on there. And then I'm going to make a copy of it, but you'll actually tear it off. I'm going to place that copy down here. You can see my angle. And when I bring it back and place it back on the post-it, I'm going to rotate it. Maybe I'm going to rotate it. There we go. Now I have my rotation tool, and I can spin it so that angle is able to be placed nicely up into the corner. Then I'll go get the other angle. Also, you're just cutting it, but I'm going to lasso it. If I avoid the black line, I don't end up with the whole line with it as well. This is your torn edge. Make a copy of this as well. Bring it on over here. I did get the whole drawing. And then let's go grab it. Place it back on our triangle. But what this illustrates is that when we take the two interior angles and place them on the outside of the triangle, we end up with, in order triple, these three angles together add up to a straight line, and that straight line is 180 degrees. The other thing to note is that those two angles, those two remote interior angles, are equal to, when we add them up, the sum of the remote interior angles is equal to an exterior angle. Which makes sense, because these two angles plus this other, the third angle, adds up to 180, and those two angles plus the third angle adds up to 180. So sum of interior angles is 180. And the two remote interior angles add up to the exterior angle. All right, so we can use this information to find the measure of each numbered angle. So when we talk about angle J, for example, angle J is an angle that also is named the angle 3. There's no degree symbol next to it, so this is a name of an angle. Angle 1 is a name of an angle. Angle 2 is a name of an angle. We use numbered angle names sometimes because it's easier than having to name a 3-letter angle name like K, L, J. So we want to find the measure of each numbered angle. So when we're finding those angles, we're going to find a triangle that has the most information. So triangle KLM has 2 of the 3 angles that we're looking for. And so if we add the 71 degrees and the 57 degrees, we get 128 degrees. And the 3 angles together should add up to 360, so 360, to 180. So 180 minus 128, went quadrilateral mode for a second there, is going to get us 52 degrees. So 52 degrees is the measure of angle 2. You can write it right next to angle 2. You can put an arrow there and say that's 52 degrees. Or off to the side, you can say the measure of angle 2 is 52 degrees. We also need to find angle 1 and angle 3. From a moment ago, we found out that these two remote interior angles add up to the exterior angle. So 52 degrees and 71 degrees should add up to angle 1. But a faster route might be simply to say I have a linear pair, and so 180 minus the 57 degrees is going to get me my angle 1. So 123 degrees. The measure of angle 1 is 123. And finally, we're ready to find angle 3, which is also known as angle J. And so we can add the 123 degrees that we just found with the 28, and that will get us a total of 151 degrees. And then when we take 151 and subtract it from 180, we get our third and final angle, which is 29 degrees. All right, second example, similar to this, is our extra example 1. Once again, we're trying to find the measure of each angle, and we have one triangle that is somewhat finished, has two of the 3 pieces, and so we'll go ahead and find the third angle. To find the third angle, we're going to take 43 and add it to 74, and we get 117. 180 minus that 117 will get us 63. So angle 1 is 63 degrees. If you remember, though, that angle 1 and angle 2 are two angles formed by intersecting lines, and the only thing they share is a vertex, V for vertex, V for vertical, angle 2 is also 63 degrees because vertical angles are congruent, which is something you have to know for this next chapter. And if we have a 63 degree angle and a 79 degree angle, together those add up to 142 degrees. And once again, 180 minus the 142 is going to get us a total of 38 degrees, or a difference of 38 degrees. You can check your work by adding all 3 angles to make sure they add to 180. Example 2, we have a triangular shaped house, and they've told us that the exterior angle, angle DAB, is 12x plus 7 degrees. So if that is 12x plus 7 degrees, it has to be equal to the sum of the 2 remote interior angles. It has to be equal to 65 degrees added to the 6x minus 4 degrees. Combining like terms, 6x plus 61 is equal to 12x plus 7. If we subtract 6x from both sides, that will take our letters to the left and we'll have 6x. In the same step, we can subtract 7 from both sides, and 61 minus 7 is 54. So if 6 times x is 54, we divide by 6, and x is 9. However, they said we need to find the measure of angle DAB, so we don't want to stop short. We want to take that 9 and we want to plug it in everywhere we see an x. And so 12 times the x, or 9, plus 7 is going to be our external angle. And so 108 plus 7 gets us 115 degrees, which is the measure of angle DAB. right, last example. We're asked to find the measure of each of these angles. So if we don't choose to put an angle 1 or an angle 2 into an angle, we have to use its three-letter combination when there's more than one angle at that spot. This first angle, angle BAC, says I need to find this angle right here. So we could have called it simply angle A. Well, in order to find that angle, we have to find out what x is. And in this right triangle, we notice it's a right triangle because it has a right angle, we're going to realize that if we've used 90 degrees up, then we'll have 90 degrees left for the two acute angles. So 9x minus 8 and 2x minus 1 together should add to be 90 degrees. Combine your like terms, 11x minus 9 equals 90. Add the 9 to both sides since it's being subtracted. Opposite of addition is subtracted. We get a 0 pair and 99. When we divide by 11, x is 9. But we can't stop at x. We need to find the measure of angle BAC. So if x is 9, 9 times 9 is 81, and 81 minus 8 is going to give us 73 degrees. So the measure of angle BAC is 73 degrees. Likewise, we need to find angle BCA. So BCA is this angle indicated by the 2x minus 1. So if we want to find this angle, we'll take the 9 and substitute it in. 2 times 9 is 18 minus 1 is 17. It does not appear that these angles are being drawn to scale. Once again, vertical angles are equal, so 17 degrees will be the other angle and the other vertical angle, and the three angles in this triangle should now add up to 180 degrees. So 11y plus 4 plus 9y minus 1 plus 17 has to equal 180 degrees. Combining your like terms, we have a total of 20y. Positive 4, negative 1, and positive 17 add up to 20. And those two together add to 180 degrees. If we subtract 20 from both sides, 20y is 160. So dividing by 20, y becomes 8. And once we know that y is 8, we substitute 8 in. 11 times 8 is 88. 88 plus 4 is going to get us 92. 92 degrees is the measure of angle CFD. CFD, 92 degrees. Then CDF is found by taking that 8 that we found for y, plugging it in. 9 times 8 is 72. 72 minus 1 is 71. So the angle at D is 71 degrees. And BCA was 17 degrees. And DCF was also 17 degrees.